Physics with Ben. Don't forget to subscribe, like, and comment on this video. I promise to make a live video series as regard to experiments in physics. And I would like you to listen very well. The practical aspect of physics is a very, very important aspect of physics. With my 8 years and above of teaching experience, I have come to understand that if students do very well in their experiments, they stand a chance of passing physics with distinctions. And so we have to talk about it today. I'll be discussing the real experiment and the one you perform physically, and then the other one, the alternative to particles. Both of them have something in common. So we have 4 branches of physics that experiments always come up from. The examiners always set exams, practical exams from these 4 branches of physics. We have mechanics. We have heat energy. We have waves and optics. And then we have electricity. So examiners always set questions in this area. They may decide to set, and the questions are always 3 for you to answer 2 of your choice. Questions and electricity, they are fixed questions. They comes up every year. As I was saying, questions from heat energy and waves, they are not fixed. Examiners may bring a question, as I said earlier, questions from mechanics and electricity. They are fixed questions. It means that every year you must see a question from mechanics and electricity. However, questions from waves / optics and heat energy, they shuffle them. If they bring a question from heat energy this year, that is mechanics, heat energy, electricity. Next year maybe mechanics, optics, electricity. But mechanics and electricity, they are fixed. Easy to pass physics practical exams if you have the right information and you know how to go about it. And that is exactly why I am making this video. Permit me to say that this channel has all it takes to give you an A in physics. So just sit back and listen for free and go and succeed. Now, I want to throw light on these branches of physics, an overview of these branches of physics, what you should expect from them. In mechanics, Experiments in mechanics has to do with the branch of physics that deals with movement of objects and the force that is responsible for their movement. What are the questions you will expect from mechanics? The experiments under mechanics, the common experiment under mechanics are number one, the simple pendulum experiment. That is simple harmonic motion. Or you will have a question from Hooke's law, elastic properties of matter. You may also have a question from knife edge, balancing of meter rule on knife edge. You may have a question from relative density or Archimedes principle. These are the major areas you keep seeing questions from mechanics. In electricity, majorly, you will see questions where you have to verify Ohm's law. Questions from potentiometer experiments, questions that have to do with the measurements of ammeter and voltmeter. Questions that has to do with the connection of the rheostat and all of that stuff. In optics and waves, you will see questions from sound waves. They love bringing experiment from sound waves. And for optics, they love bringing questions from concave mirror, experiment under concave mirror, experiment from triangular glass prism, experiment from rectangular glass block. These are then experiment from biconvex lens. I say that again. If you see any question under optics, these questions must come from these areas. Number one, questions from sound waves. Sound waves, that is from waves. Then for optics, you see questions from reflection of light on curved mirror surfaces. You see questions from refraction of light through triangular glass prism. Refraction of light through rectangular glass block. And refraction of light through lenses. That is the biconvex lens. Good. For heat energy, you see questions majorly from measurement of heat energy, specific heat capacity, the calorimeter experiment. That's all. So you have to answer just 2 questions on the D-Day, be it the real experiment or the alternative to the experiment, to the particles. So this is the overview of all the questions that you will answer on that day. So you have to prepare yourself and just answer 2 questions. I'm discussing WAEC, GCE here right now. Good. And then it is also applicable in other branches, like in the IGCSE, you have to do all the experiments, all these 4 branches, questions from mechanics, from heat, from waves/optics, and electricity. You have to do all of them. 4 of these branches, you run experiments in all of them. That is what you do in IGCSE. But in WAEC, in GCE, in NECO, you have to choose just 2 out of the 4. Now, having given us an overview of all of these questions, I want to tell us right now what is expected of you before you go into the examination hall to write your physics practical exams. Don't forget, I told us that the experiments in physics is a very, very important aspect of your exams. It stands a chance of giving you an A in physics. That is, if you do well in your theory, and you do well in your multiple choice, and then you hit it very hard in your experiment, then you stand a chance to get an A in physics. Experiments will give you a very good grade in physics. The topic at hand is how to score 50 over 50. in this experiment. Now, it will interest you to know that sometimes the reason why we don't get an A or we don't get a B is because of a silly mistake that we do. Maybe just do a silly mistake that will cost you 1 mark or 2 marks, and then you see yourself, you distance yourself from that A grade or the B grade. So the essence of this video is that you get this information and you get yourself armed so that on the D-day of any of these exams, you don't do any silly mistake that will take away a mark away from you. Remember, it is very, very important for you to pass physics, because if you pass physics exam very well, you are going for that course you want to study in your university. I really don't want physics to be the reason why you not go for the course of your choice. Your education is your life, and you have to take it very, very serious. Now, I want to give us general information on all of these experiments. As a student, what do you expect to do before you step into the examination hall to write your exams? If you are preparing for any experiment in physics, for any experimental exam in physics, you need to be grounded in the theory of the experiment. You need to be grounded in the calculations in the experiment. You need to be grounded in the graphical aspect of the experiment and also the pictorial aspect of the experiment. What am I saying? I will use one experiment for example. If you are preparing to write an experimental exam under mechanics, and if you are lucky on the D-day, they will bring questions from simple harmonic motion, especially the simple pendulum experiments. What are those things that you are expected to do? Good. Number one, since simple harmonic motion, since the simple pendulum experiment is an example of simple harmonic motion, while preparing for the exams, you have to master the definitions. What is simple harmonic motion? You have to know how to define simple harmonic motion, how to list examples of simple harmonic motion. You have to master some calculations around simple harmonic motion. That's the basic knowledge. And of course, maybe to draw some diagrams around simple harmonic motion. Good. Number two, you have to master the equations, every equation in that topic, because you don't know the question that the examiners may set for you to answer in the experiment. Number three, you have to master your graph, how to plot graphs correctly, and what is expected of you in plotting of graphs. And it will shock you to know that all of these things I'm saying, they are right here on this channel. And then you just have to click in the description box below and get the video links to all of these experimental guidelines. Number five, you need to master how to state precautions, because examiners will ask you to state precautions. How do you state precautions for alternatives to practicals and the real experiment? Very, very important. Now let me give you a rundown. If you are going to meet any exams under mechanics and precisely the topic of simple pendulum experiments or simple harmonic motion, your table of values is very, very important. Your table of values carries the highest marks. And I have done a lot of video series on how to plot table of values, on how to generate your table of values, sorry. And so you just have to click in the description of this video that you're watching right now, and you will see all those videos that I have done. Every video on experiment that I have done on the channel, the alternative to practicals and the real experiments, they are all having what you need to get your A, your 50 over 50 in that experiment. So you have to master how to plot your graphs. How to generate your table of values, the composite values, and how to go about them. For instance, if you are to plot table of values, the composite table parameters like the length of the thread, you have to write the length slash the units, length slash cm. You have to measure the time, small t. How do you write it? Small t slash seconds. You have to measure period. How do you write it? Capital T slash second. And then the column, you may have a column where you have t square or root t, or the cube root of t, or t inverse. All t inverse, t square, cube roots of all these parameters, you have to record them to at least three decimal places each. And you have to distance yourself from what is called inconsistency in recording of your table of values. Now, what do we mean by inconsistency? In one column, you're having some values written in 1 decimal places, some in 2 decimal places. We call them inconsistency in recording of your table of values. I'm doing this video and I refuse to write today deliberately because everything I'm saying here is right here on this channel. Just click in the description box below and you'll find all the videos that will help you pass your exams. Good. The second thing is plotting of your graph. When you are plotting your graph, you have to consider the axis of the graph. If you don't label your axis correctly, examiners may deduct marks away from you. And so all of those stuff, they are found in the description in the box below. Now, the last thing is precautions. How do you state precautions for the real experiment, the one you perform practically in the lab? For instance, if you are working with simple pendulum, you state precautions in past tense and then you personalize the precautions. I avoided error due to parallax while taking reading on the meter rule. Error due to parallax are error due to the usage of the apparatus in the physics lab. So you can't say I avoided error due to parallax and then you put it there full stop. No, they'll mark you down. So I avoided error due to parallax when taking reading on the meter rule. How do you take this same precaution for alternative to practicals, which is exams that are peculiar to GCE? I would have, take notes, I would have avoided error due to parallax when taking reading on the meter rule. The experiment was not performed physically. You ran it mentally. And so you don't say, I avoided. You didn't do it. You just, it is alternative. So you say, I would have. That's just a difference. Good. Question number 2. I avoided conical oscillation by displacing the bulb at a small angle. How do you take the same precaution in the alternative to practicals? I would have avoided conical oscillations by displacing the pendulum bulb at a small angle. And so there are more of these precautions, but you have to take just 2 of them. Then the BI and the BII part of the experiments is where they will ask you questions like, define the period of oscillation, define frequency of oscillation, define simple harmonic motion, or list examples of simple harmonic motion. So you see that you have to prepare before you get an A in your physics exam. And if you score 50 or 50 experiments, you stand a chance of getting an A in physics. Now, example, I'm done explaining what is obtainable in mechanics and in the experiment, simple harmonic motion. Under the topic, simple pendulum. I will choose another example. Example for under the experiments, let's say Hooke's law. Okay, I'll choose electricity right now. Electricity. If you are to run an experiment under electricity, and maybe you are to measure the readings on the ammeter and the voltmeter in the experiment, you are going to verify Ohm's law. So what do you expect to do? As I said earlier, your table of values carries the highest mark. And so I have done so much videos on how to generate your table of values from the scratch to the end. So just click in the description box below and you will see all of those video series. Thank you. Now, what do you expect as a student going into write practical exams under electricity? You have to master the theory, like what is electricity, how to state Ohm's law, how to find the resultant resistance when resistors are connected in series and in parallel. What happens to current and voltage when resistors are connected in series and in parallel. Very, very useful information. How to draw electrical circuit correctly. How to identify electrical components in the circuits. Symbols of electricity. Electrical symbols. Very, very important. The different types of electrical circuits. And then some calculations around circuits. And then you are good to go. So what do you expect? In that exams, examiners may ask you to run experiments to find ammeter reading and voltmeter reading. And also along the line, you have to answer questions like in the BI and the BI part of the questions, they may ask you to state Ohm's law, to define electricity, or define resistivity, or list the factors that affect the resistance of a wire. State precautions, peculiar precautions or common precautions under electricity as follows. Number one, I ensure tight connections of the wires. Full stop. How will you state that same precaution in alternative to practicals? I would have ensured tight connections of the wire while performing the experiment. Precaution number two, I avoided error due to parallax when taking reading on the ammeter and on the voltmeter. How do you state the same precaution in alternative? I would have avoided error due to parallax while taking reading on the ammeter and on the voltmeter. These are the precautions, common precautions in electricity. And so you have to stick to them and you add some of them today and then you are good to go. And then in the BII part of the experiment, the BI, they may ask you to define, to state Ohm's law, to define something. In the BII, we do some calculations on electricity. So you see that it is very, very simple to pass every physics exam. I'm about to end this video. Just click in the description box below and then you will, every experiment I have done, I did them deliberately for this purpose. Click those box below, the description box below, and then you find the video series and then watch all the videos. I repeat, this channel, Physics with Ben, has all it takes to give you an A in your physics exams. I wish you guys success in your exams. And if you have any challenge or any question, you can comment in the description box below and type the question there. I will respond to you on time. Thank you and God bless you. Bye-bye.